Visible light is also one of the 7 electromagnetic waves. We use visible light every day just to see things, and too much of it can blind us. This man is working on optical fibres. These are a way of sending large amounts of information over a very long distance at extremely high speeds, in fact at the speed of light. You are required to know the advantages of optical fibres over the advantages of copper wires. Optical fibres are thinner, cheaper, and can carry much more information than a copper wire. Also, the quality of a signal in copper wire tends to degrade over a long distance. We say that the signal suffers noise. As a result, when transmitting information using a copper wire, booster stations or amplifiers are needed at regular intervals to maintain the quality of the signal. Booster stations are also needed for optical fibres, but nowhere near as close together as those needed for copper wires. An optical fibre works because of total internal reflection. You will have already studied this at Key Stage 3, and you should have recapped it in your lessons. When a ray of light travelling inside a piece of glass strikes the edge, we would expect that ray of light to leave the glass block. However, if the angle of incidence, and that is the angle at which the light strikes the surface of the glass, is big, if it is bigger than the critical angle, the light will not leave the glass. In fact, it will reflect inside the glass. We call this total internal reflection. In an optical fibre, we get repeated total internal reflection. Every time the ray of light hits the side of the glass or the side of the fibre, it will totally reflect. This means very little information is lost. At any one time, hundreds of different signals can be sent down a fibre optic. The most common use of fibre optics for visible light, and the one most likely to be asked on your exam, is endoscopes. These are the cameras they use in hospitals to perform keyhole surgeries.